with the native people.
The students themselves were charged with presenting a new technology to China. So what we did was each of the students had a theme of Western culture that they were going to showcase the students to. So the students themselves are actually charged with going over and showing the Chinese how to use this web tool.
The stuff she thinks is important, she put it in order.
In education, very good. Excellent. Very nice.
See, look, like this, like, let's see.
Chinese students naturally try harder than we do because they feel like they have to be the best at everything. Being average is not an option. Many feel that when they're in high school, they have to work hard to get into a good university. If they're accepted, they then have to work harder to graduate in order to have good careers.
Working with the Chinese students to do our themes and work on our web pages, we use a ThinkQuest, which is a web page building tool, and we use the Intel thinking tools. And so I was astonished when they got finished with their work, because I'm like, wow, you did that in this little amount of time.
For students traveling abroad for the first time, this is a new experience. They're unaware of what's involved in traveling and the preparation that it takes. Through private funding, through grants, and various other opportunities, we're able to take the students outside the classroom. We feel that it's important to allow all students to participate on the trip, whether or not they have the funds or not. So most of the students put in very little money into the program, but we encourage them to put in time, effort, and work for their position on the trip.
There was one part in Harbin where we had a chance to slide around a frozen lake and then slide down this like toboggan type thing, which the kids kind of enjoyed. And really it's interesting because they get a chance to get out there and just play and be kids.
When we were walking up the wall, it was like we were in awe. You couldn't believe that you were actually there. That our feet were actually planted on this wall, and it's so historical and it's so amazing. It's like we're really there and we're walking up the wall.
I really enjoyed the opportunity to share aspects of my culture and learn about life in China. One of the best ways to experience another culture is to talk to people from other parts of the world and get to know them.
We all have the same goals in mind, and that is to educate our students, expand their minds, and become worldwide leaders in the community. We can do this, and we can extend outside the classroom.
I really consider myself very fortunate for the opportunity to visit China. I saw great and wonderful things, but most importantly, I made new friends. Well, that's it for now. Back to you, Daryl and Joanna.
One day in the city of Dallas. 516,000 alarm clocks wake up the city. Millions of cars commute to work, and 2,500 planes take to the sky. One day in the Dallas Independent School District, a masterpiece is perfected. Records are broken. New worlds are explored. And the promise of tomorrow becomes a reality. Think you know DISD? Think again.
What's up, you guys? My name is Daryl, and we're where it all happens behind the scenes of Calculus Live. Thanks for tuning in for today's show. But before we get started, we just want to cover a few ground rules. So let's head over to my man Ivan for more.
Okay, good luck on your problem. Okay, ground rules. Let's see. You have to call in. Pick up the phone, give us a dial, give us a ring. I mean, we really want to hear from you. The number to call is 972-925-3123. Take a picture, write it down, just give us a call.
Number 2, when you do call in, step away from the television. It really hurts our ears and it sends off a really bad tone. See what I mean? So, when you call in, step away from the television. I thank you, our hosts thank you, and our ears definitely thank you. And another thing, when calling into the show, please do not use cell phones. Cell phones do not work too well with our audio system here in the studio. They give off a really bad signal and we have a hard time hearing what you're saying. So remember, no cell phones. Another thing that we want all of you out there watching to know is that you could be on TV. That's right, your face could be on the tube. Send us a picture, whether it be an individual photo or a photo of your entire class. We'd love to see you, and so would everyone else out there watching. Either mail it to us through interdepartmental mail at DISD Box 379 or drop us a line at calculuslive@dallasisd.org. Okay, well, it seems like it's just about time for the show to get started, so I have to say goodbye for now. But don't forget to call in for your chance to win all sorts of cool prizes. So get set for our all-new edition of Calculus Live.
Call in and we'll work calculus problems together. Let's meet my student assistant for today.
I'm Alex Shapiro. I'm in Mr. Irby's calculus class at Woodrow Wilson High School.
Alex is a junior, so she gets a little time to decide on that college. Remind the students of how they could be on Calculus Live, Alex.
If you'd like to be on Calculus Live, just have your teacher email Ms. Harmon at jharmon@isd.org.
We are counting down until the AP Calculus exam on May the 3rd. Alex, how many days do we have to prepare?
There are 27 days.
Let's get ready to rumble!
We should get right to work. 27 days is enough, though you can do a lot in 27 days. Alex, who's our first caller?
Our first caller is Erica from Molina High School.
Erica? Erica? Erica?
Molina, yeah.
Erica? Are you there? Hi, Erica. Is this Erica?
Have you been in all the rooms?
Erica?
What room did you all check?
I can hear you. Who have we got now? You think we still got Erica on the line? We've got, who's our next caller?
Our next caller is Christian from Adamson.
Hey, Christian.
Hello?
How are you, Christian?
Fine.
How are those Adamson ladies doing?
Fine.
Good, good. You ready to work a problem?
Yes.
Okay, let's see what we got for you. How's Mr. Bentley?
Fine.
Good. You got any refreshments today?
Oh.
No, you're just having to just work calculus problems with no food, huh? All right.
That's right.
Here we go. Can you see this problem?
Yes.
The slope of the curve at any given point can be found using, that's x cubed, y minus 1. Solve the differential equation, finding the particular solution that passes through 0, 3. Do you know what to do?
Yes.
All right, go for it, Christian.
Yes. dy dx equal.
Very good. You understood when they said the slope that they were talking about the derivative. All right, what's next?
Now we're gonna separate.
Separate. That's going to get you a point. Tell me what to write.
Okay. dy divided by y minus 1
Perfect.
equals x cubed dx.
That's 1 point on a free response. These are worth a ton of points. Keep going.
Now we're gonna integrate.
Integrate. There you go.
Can we rewrite it?
How would you like to rewrite it?
X No, it's gonna be the ln of.
Very good. It's going to be the ln. dy over y minus 1 is ln. Good job. Keep going.
X to the 4 divided by 4 plus c.
Perfect. Now what?
The point is, we're gonna solve for c.
All right.
So we put ln of 3 minus 1
Good job. Equals?
0 to the 4 over 4.
What does that give you?
So c equals the ln of 2.
C is ln of 2. Let me get some extra paper here. ln of 2 equals c. Now let's check our points. You got a point for integrating that and a point for integrating that. You're going to get a point for c. This thing is full of points. You've already got 1, 2, 3, 4, maybe 2 more. Okay? Tell me what to write.
Okay, now we're gonna write the equation with the c.
All right.
We found.
Okay, tell me what to write. Good job.
The ln of y minus 1 equal x to the 4 over 4 plus the ln of 2.
Now I'm going to move it because that's all you need to see now, isn't it? Keep going.
No, we're gonna solve for y.
Okay, tell me how to do that.
e to the ln.
E both sides. Exponentiate both sides. That's right. Keep going.
Now we have y minus 1 equal 2 e to the x to the 4 over 4.
You did that beautifully. Now for some of our viewers, that's e to the power times e to the ln of 2, and you immediately went to this step. That's great. One more step. That's a point.
Now we add 1 to both sides.
1 plus 2, okay with you?
Yes.
That is beautiful. I want to recommend that you double check your point 0.03 and make sure it actually fits. Okay? So let's check it. If I put a 3 here, that's 1 plus 2e to the 0. Is that 3 equals 3?
Yes.
It is. So that way, if they give you the other branch, you know, you'll have a chance of realizing if you've done something. You did perfectly. You did everything exactly right. That is worth a ton of points. Those questions are usually 6 points, and that's worth learning how to do. And look at you. You've already got it.
Okay.
Hey, double bells. Thank you for calling in. You guys call back. Who's our next caller, Alex?
Our next caller is Charles from Carter.
Hey, Charles.
Hello.
Hi, Charles. Who's your teacher?
Miss Blackwell.
Miss Blackwell. Good. All right, Charles. I don't know why I said who's your teacher. I knew who your teacher was. Here we go. This is a problem that they love. I see this problem all the time on the test. Hold on a minute. The machine's going crazy, but it's better now, Charles. All right. How is Miss Blackwell today?
She's doing fine.
Is she fine? Yeah. Is she in that new room yet?
No.
Not yet. Okay, Charles. This is a limit. I'm sorry. There we go. It's a limit problem as x goes to infinity. Can you see the numbers well enough?
Yep.
And this is on almost every test. And you know what? This is one in our pocket, isn't it? Do you know the answer?
-2.
You know what? That is beautiful. That is one you can do in 1 second and move on to another one, right?
Yep.
So you'd want to be sure if that's number 45, make sure you get it worked. Don't get bogged down in one and not get to one like this. It's so easy. True?
Yeah.
True. Thank you for calling in, Charles. You guys call back.
Okay.
Who's our next caller?
Our next caller is Brittany from Skyline.
Hi.
Brittany, you have quite a fan club.
Yeah.
Yeah. Who's your teacher, Brittany?
Miss Johnson.
Miss Johnson. Do we have your picture?
No.
No? Well, that's okay. We're going to forgive you for that.
Tell
okay?
Ivan I said hi.
Tell Ivan you said hi. Ivan, she says hi. Ivan says hi back.
Excellent.
I think that was Ivan shouting. Did you think it was Ivan?
Yeah.
Yeah, I think so too. All right. Hey, did you finish out the 6 weeks really well?
Yes.
Excellent. Okay, here we go. dy dx equals square root of xy, and y of 4 is 1. Solve the differential equation with that given point on the curve. Do you know what to do? It's a little tricky, isn't it?
You want to rewrite it.
You want to rewrite it. Tell me what to
pretty
rewrite.
heavy.
Dy over dx equals the quantity xy to the half.
All right. Now what?
And then you want to give x and y on x on it.
Oh, that's perfect.
Oh.
I like that. Somebody in the studio likes it too, right?
Yeah.
I think somebody's learning calculus.
Now you want to separate.
Yeah, baby.
So tell me what to write.
dy over y to the half
Perfect.
equals x to the half times dx.
That's a point right there. You knew to separate the variables. If you don't do that, do you know you get no points? You can play around with this thing all day, but if you don't separate the variables, they don't give you any points. So that's a good thing to do. Keep going.
Then you want to integrate both sides, but since it's not the natural log, you want to bring y to the top. So
Very good. It's not natural log. You're exactly right. So tell me how to bring it to the top. What do I write?
y to the negative half
Good.
dy times x to the half dx.
So we got
equals x to the half
you
dx.
said it perfectly. That's exactly right. And now what do we need to do?
Integrate.
You're going to get a point for each one. So you know what that means? If you can only do one, go ahead and do it. Now, I know you can do them both, but you know what I'm saying? Do whatever you can. Keep going.
And when you add, you always add one, so it'll be y to the positive half.
Good.
And divided by a half
Okay.
equals x to the 3 halves multiplied by 3 over 2.
By 2 over 3?
2/3.
That's right. Good. Plus?
Plus b.
Our favorite letter. All right. You want to clean this one up a little bit? If you
Uh-huh.
divide by half, you can multiply by what?
2.
2, y to the 1/2.
Uh-huh.
And I'll just rewrite x to the 3 halves plus c. Now, do I need to move it down so you can see the given ordered pair?
Since you're given x equals 1 and x equals 4 and y equals 1, you want to solve for c.
Very good. 4 for x, and you said it exactly right. Okay, so let's solve for c. What do we get?
2 times 1
Okay, I'll go ahead and write that so you don't have to worry about it.
equals 2/3 times 4 to 3 halves. Let's see.
A little messy. What's this side?
2.
Very good. Equals. Now let's leave 2/3. All right. 4, what do you want to do first?
You want to do the square root of 4 to the cube.
Excellent. So the square root of 4 is?
Square root of 4 is 2.
And 2 cubed is?
8.
8. Great. That's just the way I would do it. And so now I've got 2 equals 16/3 plus c. Can you figure out what c is?
C is 2. It'll be.
You want to change this to thirds?
Yeah, it'll be 3. It'll be 6 over 3.
6 over 3 minus?
Minus 16. It'll be 10/3.
Plus or
Negative
minus?
10/3.
Good job. All right, let me find back up here. This is where we go back to. Can I call it 2 square root of y? Would that be okay?
Yeah.
Equals 2/3. I have to copy what you said earlier. 3 halves minus 10/3. That's a half. I'm sorry, I kind of messed that up. All right, now, how do you get y equals out of that? Jeez.
You want to solve for y, so you divide both sides by 2.
Tell me what that would give me.
The square root of y equals 1. I could say 1/3.
You sure could say that. And there's a number of ways you could say it. Minus,
20 over.
divide by 2.
Divide by 2, right?
Uh-huh.
Yeah, it is 5 over 3.
There you go, 5 over 3. And then what's the last step? I didn't have it where you could see it, did
You
I?
want to square both sides.
And what does that give you? Just
The
put a big
quantity.
old...
Yeah.
Right.
Yeah.
Are you really going to do any more?
No.
Goodness, no. We're through. We've done enough work for this one. That is a beautiful job. Remember, that's usually...
Hey, that was easy.
It's easy for them to say. That's usually 6 points, and that is a lot of points on a 9-point free response, isn't it? You did a beautiful job. I love the way you got through that problem. Excellent, excellent, excellent. That is a double bell response. Double bell, please. Good job. You guys call back, okay?
Okay.
All right. Who's our
Our
next caller?
Our next caller is Quay from Lincoln.
Hey, Quay.
How you doing?
I'm fine. How are you doing?
I'm doing all right.
Do you want to say hi to anybody?
Hey, Mama.
Y'all got a giant crowd out there today, huh?
Yeah.
Excellent.
Yeah. Hey, yeah.
I've got a problem here that looks like lots of stuff going on. Let's see if you like this problem. Okay?
Let's see.
Let me see if I can get it where you can see it. All right. Can you see all that? Oh, that's scary looking, isn't it?
No, I can't. Quite frightening.
You can't see it?
I got it.
Can you see it? It's a little hard. I know. Let's focus on what they ask. Okay. Based upon the values given, for which function does it appear that the limit as x approaches 0, okay, that's focusing right here, the limit is 2. So you're going to be looking at the approach from the left and the right. And we've got function f, g, and h. Which of those appear to have a limit of 2?
Whoa! I couldn't hear you.
Which of those appear to have a limit of 2 as x approaches 0?
F.
Say it again.
F.
F? All right, let's check. You're approaching 2 from the left and 2 from the right, and in fact you're at 2. I agree. F is good.
Correct, boy wonder.
What about G? What about G? Is it approaching 2 from the left?
Yeah, no.
No, it looks like 1, 1, 1, 1, 1, and then suddenly it jumps to what? 2, 2, 2. Is that a limit if you're going 1 and then you jump up to 2?
Yes, ma'am.
Is that a limit?
No, that's not.
That is not. So we're going to give G the X.
Yes, ma'am.
Now look at H. You're approaching 2 from the left. What do you think? 1.9997?
Oh, yeah.
What about from the right? 1.9997?
Yeah.
What about if there's nothing at 0? Is that okay?
Yeah, it's okay.
That's okay. So which two have limits that appear to be approaching 2?
Functions F and H.
F and H. Very good. This is another way of asking a question, like if I said to you, at A, does this function have a limit? You'd say, no, it doesn't have a limit. It's jump discontinuity. But if I said, does this have a limit? You'd go, well, yeah, it's approaching from the left and the right.
Oh.
Hey, good job.
All right.
You guys call back.
Thank you.
You're welcome.
All right.
Who's our next caller?
Our next caller is Yvonne from Sunset.
Hey, Yvonne. We got your picture? Let's see your picture, Yvonne.
Oh, whoa.
Hey, it's Ivani!
No, it's
You've already got a round of applause and you didn't even have to work a problem, right?
Yeah.
That's pretty good. How's everything going at Sunset?
How's everything at Sunset?
Yeah.
Good. Spectacular.
For what?
Spectacular.
Spectacular. I like hearing that.
Hello,
Spectacular is
everybody.
the way to be. All right. I've got a problem for you here. It's kind of geometric. Do you like geometry?
Yep.
Who was your geometry teacher?
I don't remember because I don't know.
Been too long ago.
Yeah.
You're too mature.
Cool.
It's either that or a bad geometry teacher.
Oh. They say we'll remember two, one really good and one really bad.
Yeah.
Yeah. All right, here we go. This function consists of a line segment
Right.
and a quarter circle. It may be hard for you to see the numbers.
Yeah, it kind of is.
This goes up to 3 and over to 5, and then we start the quarter circle going to 8. Okay?
Okay.
So I'll draw a little line here to help you see that.
All right.
The quarter circle starts at 5 and goes to 8. So you can see the radius. This is a box. All right, I want the average value of the function from 0 to 8. Do you know what to do?
I can't hear you.
I want the average value of the function from 0 to 8.
Integrate A to B. Hold on. I'm trying to remember the song.
Well,
1
I'll
over
help you.
B minus A?
That's right. Integrate from A to B, the function, over B minus A. Or you might put 1 over B minus A out front.
Right.
You could do that. Okay, well, here's the problem. We don't know the function. But what's another way to integrate?
Find the area?
There you go. Find the area. And you said 1 over B minus A. Well, that's 1 over 8. And now all you need to do is find the area of a rectangular box that is 5 by 3.
And 3, yeah.
What's that?
15.
15. Plus the quarter circle, which is how much of a circle?
I don't know.
Semicircle's 1/2. What's a quarter circle?
A fourth of a circle?
A fourth. Pi. Radius squared. Your radius is from 5 to 8. What's the
4.
radius?
4. 1, 2, 3, 4. Isn't that what it said? 3?
1, 2, 3. I think it's 3. That's okay. You know what? I put 4 on my answer too. It's 3. So actually, that's a good answer, isn't it? We could stop right there, couldn't we?
Yeah.
That's a perfectly good answer. So let's stop right there. Good job.
Good answer.
You call back, okay?
Give us the bill!
Who's our next caller?
Our next caller is Ruth from Adamson.
Hi, Ruth.
Hi.
How are you?
Fine.
Excellent. Ruth, have y'all done volumes of revolution?
Yes.
Area under curves?
Yes.
All of that good stuff?
Yes.
Have you done the second fundamental theorem of calculus?
Yes, we've done that.
All right. I'm going to give you a problem, and let's see what you think. And I'm going to get my calculator out. Now, I'm going to use an 8384. Is that okay with you?
Yes.
That's what I have handy. And I think I've already plugged it in. Let's read the problem first, and then you can tell me. You can tell me and the Flintstones what to do on this, okay?
Okay.
If f is an antiderivative of this, such that f of 1 is a half, then I want f of 0. Do you know what I'm talking about? If f is an antiderivative, then do you know what this is?
We're gonna do the integral
We are. We're going to do the integral of what?
of the function.
That's right. Integral of the tangent squared of x over x squared plus 1 dx from what to what?
From 0 to 1.
Perfect. You knew exactly what to do. Equals, tell me what it equals. We'll set it up and then we'll go to the calculator.
Good answer.
F of 1
F of 1,
minus f of 0.
0. Now, which of these do we know?
F of 1.
It's 1
It's
half.
1/2.
We can get this with the calculator, and then we'll solve for f of 0, okay?
Okay.
All right, let me get the calculator ready, because I want us to practice the calculator a little bit today, okay?
Okay.
All right, this is like an 83, 84 version. Let's see if we can make it behave here.
Well, no.
All right, let's see if I've got it plugged in already. The tan of x quantity squared over x squared plus 1. Let's get it where you can see that I actually got it right.
Okay.
Does that look good?
Yes, that looks.
All right, let's go to the home screen because they tell us it's better to integrate on the home screen. So tell me what to type in to get the integral.
You're gonna go from math 9, bars, white bars, enter, comma x, comma 0, comma 1.
Was it 1 half?
Yeah, 1 half.
Yeah, I moved it where you can't see it. And so that's going to give me the integral of that function in y1 from 0 to a half, and there's the answer. Now I'm going to go put...
It was from 0 to 1.
You are so correct. So now, you know what? I could pretend I did that on purpose, but I didn't. Second enter brings it back, right?
Yes.
I don't have to retype the whole thing. And it was 0 to 1. Thank you. I would have wondered why the answer was all wrong. Let's try one more time. Ah, that looks better.
Yes.
Now that's 0.344639, okay?
Okay.
I'm going to move over and write that here. 0.344639-ish. All right, let's get back. Okay. And so I said a half minus f of 0 is this. So now can you tell me what to write to get this correct?
You're gonna move the 1 half over, so it's gonna be minus 1 half.
Okay. I'll put 0.5. How's that?
Yeah, that's fine.
That's negative f of 0.
Divided by negative 1.
That's right. So negative here, positive here, and positive here. So somebody in their calculator needs to type 0.5 and take away 0.344639. True? Well,
Yes.
that could be us, couldn't it?
Yes.
Let's see. Let's get where we can see. Okay, this is minus 0.5, and then we want to change it times negative 1, and we get 0.1553. True?
Yes. Yes.
Let's write that answer down. Woo! 0.1553 is f of 0. How many places behind the decimal?
3.
You need at least 3. You can write 4 if you want to. They're going to look at the first 3. You can round if you want to, but that seems a little dangerous.
Yes.
You can truncate. You can just stop at 3. Whatever your calculator says, you can put 155 and let it go at that. Okay?
Okay.
But it's okay to write the fourth one. They're only going to look at 3. You can write 10 if you want, but don't waste your time, right?
Yes.
I wrote a bunch so you'd know that I wasn't rounding ahead of time. I was going to keep that in the calculator and then go ahead and clean it up. Hey, good job. I'm so glad you recognized that was the second fundamental theorem of calculus. You know, sometimes when you get to college, that's the kind of thing they'll ask you, like a trick question. What is the second fundamental theorem? And you know.
Yes.
You'll be in good shape. Call us back, okay?
Okay. Bye.
Here's our next caller.
Our next caller is Crystal from Carter.
Hello?
Hey, Crystal. How are you? Good. Nice to hear from you. Let's see what we got here. I was looking for something that I thought about the other day. Let's try this one.
Okay.
The derivative of the inverse. We've done some of these before, haven't we? If f of x equals x to the fifth plus 1, find the value of the derivative of the inverse of x when x is 2. All right, if x to the fifth plus x equals 2, I want the derivative at 2, so I need the derivative of this at something else. Do you know what that is?
No. The derivative of that at 2.
Yeah, I'm going to get the derivative of the inverse at 2, so I need to know what x makes an answer of 2 in this one. What x goes with 2 in this one? What plus itself do you think will give me 2?
Uh-oh, we're losing him.
1.
I know, there you go. Now, see, that was not too bad. So it's the point 1, 2. In the function 1, 2, so in the inverse, we'll be looking at 2, 1. All right, if we know the function has the point 1 that matches this point in the inverse, can you tell me what to do? I need to take a...
The derivative.
That's right. What is the derivative?
5x to the 4th
Well, no.
plus 1.
And when I plug a 1 in, now remember I'm plugging in this one. When I plug a 1 in, what do I get?
You get 6.
And so what do I get for the derivative of the inverse? If I've switched x and y's, what happens to this derivative? 1 over 6. Isn't that a good problem?
Yes.
I like that problem because if you know the trick, you're good to go, right? And you knew the trick.
Yes.
Hey, thank you for calling in. You guys call back.
Miss Harmon.
Yes. Yes. Uh-oh. Are you gone? Have the next caller ask me what your question was, okay, Crystal? Somebody else from Carter, call in and we'll see what you needed. All right, who's our next caller?
Our next caller is Rodolfo from Skyline.
Hey, Rodolfo. Who's your teacher?
Ms. Johnson.
Miss Johnson. Say it again.
Rodolfo had to leave. This is Eddie.
Oh, this is Eddie. We were going to show Rodolfo's picture. Eddie, have we got your picture? We do,
Yeah.
don't we?
Yeah.
All right, let's see if we can show your picture, Eddie. Let me get it ready. Drum roll, please. That's you?
Yeah.
That is you. Eddie, you look like you're really into calculus. You look like calculus is your favorite subject.
It is.
Excellent. I'm glad to hear that. Oops, let me get the picture back in the right place. All right, let's try this problem. Here we go. You had to look at my speckled board here. Uh-oh.
No way, dude.
I was in too close for your picture. Now I'm better. All right, do you like this kind of problem, Rodolfo?
Eddie.
I'm sorry, Eddie. I was looking at the list instead of listening to what you said. Do you like this kind of problem?
I guess. Anything.
Okay, Eddie, let's go for it. Eddie, sit back a little bit from the TV. We're getting some echo.
Is that?
That'll be fine.
All right. You got to separate the constant from the function.
Yeah, okay. Tell me what to write. Integral from 1 to 5. Plain old 3 good?
Yeah.
Minus?
Minus f of t. 2 minus, yeah.
That's right, from 1 to 5, f of t.
Yeah.
And don't forget the dt. They take off in college for that sometimes. All right, good job. Now, this is what we're looking for, f of t, so let's leave it alone for now. What can you do, Eddie?
You integrate the 3.
All right, what do you get?
3x dt. Oh, wait.
No, you're
3t,
good.
my bad.
Yeah, that's okay. 3x
From 1 to 5.
All right. I'm going to keep this like it is. I'll go ahead and write it so we can see it when I move this down the page. Okay. Now, what do you get over here?
Do the fundamental theorem of calculus.
Okay.
So
What does
it's
that give you?
15 minus 3.
15 minus 3.
Yeah. I'll get to 12. Oh, okay.
That's right, it sure will. So you said 12 equals, I'm sorry, not equals, that's my mistake. 12 minus 2, integral from 1 to 5, f of t. Eddie, do you remember what we're looking for? Sometimes I forget by the time I get to the bottom of the page.
Okay. Now you got to subtract the 12 from the 18.
Okay. Negative 2, integral from 1 to 5. I'm just going to say f. Is that okay with you? So subtract 12 from 18 gives you what?
6.
All right. Eddie, you're looking for the integral from 1 to 5 of f. So what do you need to do?
Divide by negative 2.
Perfect. What does that give you?
Negative 3.
Are you through?
Yeah.
Yes, you are. Good job. You did a great job on that. Let's have some bells. Eddie, thank you for taking over the phone. Thanks for calling in. You guys call back. Who's our next caller?
Our next caller is Esmeralda from Skyline.
Hey, Esmeralda. Who's your teacher?
Hello?
Esmeralda? Hi, who's your teacher?
Miss Johnson.
Miss Johnson, do we have your picture?
Yes.
All right, we'll get your picture out in just a minute. I've got a question for you while we get your picture ready. I think she's already got your picture ready. Let's see if I can make it show you real fast. There you go. It looks like a snowy scene out there, but I bet it wasn't, was it? We didn't have snow, did we? Very nice. Thank you guys for sending in those pictures. Thanks, Miss Johnson, for taking them. All right. Hey, are you planning on coming to the practice exam April 21st or 22nd? Are you there, Esmeralda?
Yes.
Are you planning on coming to the practice exam at Townview?
Yes.
Excellent. All right.
Hello, everybody.
I've got a table full of stuff. Here's what I want you to do. Estimate the derivative at 2.4. Do you know what to do with that?
So you would use the mean value theorem?
That sounds okay to me. Tell me what you want me to write.
F at B minus F at A all over B minus A.
So you're going to do a slope.
Yes.
I think that's a good idea. Slope is a good thing to do for derivative. Now, what are you going to use for your slope? You got a lot of points up here. What would you like to use for your slope?
2.5 for B.
For B.
And 2.3 for A.
I like that. So you're going to use I'll write it down, 377 minus 3.677 over
2.5 minus 2.3.
And we're going to need a calculator, aren't we? All right, does everybody see that? So we can go to the calculator now. Oops, wrong one. You probably use an 89, but I'm going to pull out my 84. Is that okay?
Yeah.
They both know how to add and subtract, don't they? All right. Now, what do I need to do when I'm going to type this in? You got any tips for me?
That's a little joke.
What should I do?
What was your question?
What should I do? You got any tips for me on typing it in?
Oh, I use parentheses.
Excellent. 4.377. And also, I'm saying this to me, make sure you type right. Sometimes I type it wrong. Divide by, do I need parentheses again?
Yes.
I certainly do. Take away 2.3. You are doing a symmetric difference quotient. You went out on both sides of the point equally. That is a great way. That's what your calculator does. What'd you get?
3.5.
The slope is 3.5. I like the fact that you understood that to get a derivative when you don't have a function, you use slope. That's the best you can do, right? Now, sometimes people like to go these two and sometimes these two. I personally like that symmetric difference myself. I think that's usually the way they set them up. But they'll probably set it up where you'll be okay whichever of those methods you choose.
Oh, okay.
Hey, thank you for calling in. You did a
Thank you.
great job. Who's our next caller?
Our next caller is Veronica from Sunset.
Hi, Veronica. Got your picture? We got your picture, Veronica?
Yeah.
All right, we're going to show it.
Show it! All right! Let me see that picture!
There's a big drum roll we're getting. We're getting it ready, okay? Here we go.
There goes a lot of Victorians! Hey, you look good! You look good!
Excellent. That looks very nice. I like the bison. All right, here we go. We got a problem here. You might have seen something like this earlier, and I may have to help you with what this says. It's a little hard to see.
Hello?
Hi, I'm here. I'm telling you that the function g of t is the integral from 0 to x of e of t cosine of e to the t dt. What did I just tell you about g and this thing inside? It's the what? If g is the integral, then this is what? It's something we studied all fall.
The derivative?
It's the derivative, yeah. All right, so if you want to integrate to get g of 0 and g of 2, what do you need to integrate to get g of 0 and g of 2? What do you need to write? You need to write the integral from what to what?
From 0 to 2.
That's right. Of e to the t cos of e to the t dt. Now, tell me what that'll give me. If that's g's derivative, then I'm going to get g of what?
2.
That's right. I'm going to get g of 2 minus g of 0. That's that fundamental theorem of calculus again. Our book calls it number 2. Some books call it the first one. You have to just be prepared for whichever book you're using, right? All right. So, do we know g of 0?
Yeah.
Yes, we do. It's a 1, right?
Yes.
Okay. Now, do we know how to integrate this?
I'm sorry, I can't hear you.
Oh, okay. Let me try again. Do we know how to integrate this?
You bump up and divide.
Well, you would bump it up and divide if it were a power. That's true. Let's look at this again, okay? You want to do it on the calculator?
Huh?
Do you want to do it on the calculator?
Yeah.
Okay, let's do that. That'll be fun. All right. I'm going to put it in my calculator. I've got an 84 here. And you have your calculator nearby? Or got somebody sitting with you that got a calculator?
Yeah.
All right. I'm going to type it in y1, e to the, if I can find those keys, e to the x, and then I need cosine of x, no, cosine of e to the x. And first we've got to make sure I typed it right. Did I type it right?
Yeah.
Okay, that's in y1. So what do I do to get the integral from 0 to 2? Go to your home screen and type what? Math?
I'm using a TI 89.
Oh, you're using an 89. I'm so sorry. Well, can I just go ahead and say Math 9? Is that okay?
Yeah.
And you do it in your 89.
Okay.
Okay? And then it's vars, y vars, function y1, comma. Now, is it similar? Do you type an x?
Yeah, you put x.
Okay, comma.
0.
Comma, 2. Okay. And so that's the function integrated. Now, can you tell me what I need to add to that to get the answer? Because that, let me go back to the screen. Let me get it back in focus for you. I think I went the wrong way. That answer was 0.0523 blah, blah, blah equals g of 2 minus 1. So what do you do to get g of 2?
You gotta add 1.
You're going to add 1. Can I just do that?
Yeah.
That's a short way to add 1, isn't it? Good job. I like the way you recognize this is fundamental theorem. G is the integral, so this is g prime. How do you get from g prime integrated to these? You do your fundamental theorem of calculus, second version, most people call it. Okay?
Okay.
Hey, you did a good job. Those are ones that I think they're going to ask us, so we'll be prepared on that. Thanks for calling. Who's our next caller?
Our next caller is Avante from Lincoln.
How are you doing today? How was your 6 weeks? Did you make 100 on your 6 weeks test?
Huh?
Did you make a really good grade on the 6 weeks test?
Of course.
Of course.
I'm Mr. Calculus here at Lincoln.
What is that?
I'm Mr. Calculus at Lincoln.
Oh, well, you're Mr. Calculus at Lincoln. I am so impressed. Hey, you know what?
Yeah, that's my nickname.
That's your nickname. That is a good nickname to have. Listen, you guys got a lot going on. You've got that tutoring program that Jaslyn runs. You're Mr. Calculus.
Yeah, she Miss Calculus.
She's Ms. Calculus, huh?
Miss.
Did she get to go to A&M?
Yeah.
Yeah? How'd that go? Did it go well for her?
Yeah.
Excellent.
She was homesick, though. She missed that good old calculus.
Well, of course she'd miss calculus, but she's going to love A&M. All right, here we go. I've got a problem for you. Can you see it?
Not really. I see a 0 and is it like a negative pi?
It is 0 and negative pi. Can you talk a little bit louder, Avante?
All right.
All right. It is 0 and negative pi. You read that beautifully. Now let's focus on sine of x over 2 plus cosine of x, Mr. Calculus.
Okay, you're going to use U du.
Okay, tell me what to write.
The U is 2 plus cos.
2 plus cos of x. Okay.
And the du is sine. Negative sign.
Thank you, Mr. Calculus. That's exactly right. Negative sign. So
It-
what do you need?
It was there all the time.
I know. You knew it. You said it. Now what?
You gotta change your limit.
Change your limits. I like the way you think. All right. 2 plus cos of negative pi. Geez, I don't even know where negative pi is. Do you?
If you draw that unit circle, yeah.
There you go. So 2 plus what?
Ain't that minus 1?
There you go. So 2 minus 1 is?
1.
I like that. And then 2 plus cos of 0. What's cos of 0?
1.
1. 2 plus 1?
3.
See, those are easy things for Mr. Calculus, right?
Oh yeah.
Keep going. Now what?
Oh, you want to put your you want to integrate? You want to put it back in the?
Okay, tell me what to write.
Okay. Du negative.
Good job. Negative du over u, which is like your favorite, right?
Of course, because it's an integral.
Because what is it? That's right.
The natural log of u.
The natural log of u. And since we've done plug-ins, sorry, 1 to 3, and don't forget the negative. Thank you very much. And so what do I get now?
Well, you gotta plug in your limit.
Okay, negative ln
of 3.
3 minus negative.
Natural log of 1.
And what is natural log of 1?
0.
So that's not even going to be there. They're going to write this if it's multiple choice, aren't they?
Yes.
You did a great job. I like the way you handled that. You knew how to evaluate. I use that in circle. I use the unit circle when I need it for something like that. Hey, Avante, good job. Call us back.
All right.
Thank you. Who's our next caller?
Our next caller is Ben from Brian Adams.
Hey, Brian Adams.
Hey.
How are y'all doing? I was over there watching a baseball game the other day.
Oh, how did it go?
Well, it went well for one team. You know how that goes sometimes. Actually, both teams look great. Both teams did a good job.
Thank you.
So, do you play baseball?
No, I play basketball.
Oh, do you? Well, how'd that go?
It was fun.
Yeah. Are you a senior?
Yes, ma'am.
Okay. Ben, you ready for a problem?
I am ready.
You are ready. Let's see if I can find a really good problem.
They call me King Calculus.
They call you King Calculus. I tell you what, y'all are something else. Y'all are just all about calculus all the time, aren't you?
Yes.
I want us to do a little slope field. You know, I'm going to tell you why I want to do this, because I gave a test today, and some of my students didn't draw their slope field as well as I'd hoped. Now, it was only 1 or 2, I'm sure. But I thought maybe you could help me draw a couple of slope fields, okay? Now, I'm going to pick, I whited that point out. Can you see I whited it out? I didn't like it. So let's pick the point 1, 0. Is that okay with you?
Yes, ma'am.
And that's this one right here. Would you tell me the slope at 1, 0? And I'll put a little list here for slope. At 1, 0, what's the slope?
2.
Let's see, it's 2 times 1 is 2 over 1. Yeah, that's perfect. The slope is 2. How do you draw a slope of 2?
What?
How do you draw a slope of 2?
To the right, like this.
Yeah, over 1 and up 2. So I'm kind of eyeballing it
Yeah.
to make it look like that, okay? Now let's do 1, 1. And I want to recommend that we be a little careful, because a slope field only has usually a couple of points. And so if you miss 2 or 3, you might not get any of them. All right, can you plug that in and tell me what you get for the slope?
1.
You got 1. You're faster than I am, too. Yep, okay. So over 1, up 1, so it's not as steep looking. And now let's do over 1 and up 2.
2/3.
Say it again.
2/3.
All right. And 2/3 would be a little less steep than 1. So you make them look positive, but not as steep. You know, this is the steepest and on up. Hey, that's a good job. You know, it'll say find the slope at the points indicated. Usually 9 to 12 points. They're not going to ask you a million of them. Okay?
Thank you.
And let's do the point 1. Let's see. No, that's enough. You know what? We're going to call it quits. Sometimes you need to take a break, don't you?
Yeah.
Thanks for calling in. You call back, okay?
All right, thank you.
All right, bye-bye. Who's our next caller?
Our next caller is Kemuel from Carter.
Hey, Kemuel.
Hello.
Hey, did y'all have a question a minute ago when y'all called in?
Yes, it was about the, we had a review.
Uh-huh.
I think it was problem number 22.
Yes?
Yeah, I think we had the same problem.
Was it the one that had find it at 12 and it should have said 18?
Exactly.
Try putting 18 in. I think it'll work.
Okay.
Okay?
All
I
right.
think it's 18. If not, I bet Ms. Blackwell can tell you what number goes in there. But I believe I worked it out and realized there was a mistake. I think it needs to be an 18.
Okay.
Let me know if that works, okay?
I will.
Did it seem horrifying? Because you got an X like 2 point blah, 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 right?
Mm-hmm.
That's pretty horrifying. All right, let's see what we got here. Nope, that's not it. Here we go, volume of a solid. Have you done volumes of a solid?
Volumes of a solid?
Uh-huh.
Yeah, I played with it a little.
You played with it a little. Hey, that is good enough. Let's do this one together. Find the volume of the solid generated by oh, it's not showing yet, is it? Well, I'm going to wait a minute. Do. We could talk about the practice exam at Townview, April 21st and 22nd.
Woohoo.
Oh, won't that be fun?
Man, it's going to be a plan.
You know what? W.G. White's having prom, but my students are all going to come do the calculus test. They said, hey, prom? No.
Oh, man.
Actually, they said the opposite. They said, we're going to prom.
Yeah.
But I told them they could come Friday night, right?
Yeah, right.
All right, here we go. Let's get this problem up.
All right.
I'll tell you what it says, okay?
All right.
Y squared equals 4x.
Y squared
equals 4x. And y equals x.
And y equals x.
And we want to go about the x-axis. Here we go. Yay!
About the x-axis.
All right, so let's draw a picture first. Could you draw a picture for this one? I can draw y equals x.
Yeah. Okay.
That's easy. I'll draw that one. I'll make you draw the hard one.
Oh, man.
Now, y squared equals 4x. Can you change that into y equals?
Yeah. Go ahead and do y equals 2x.
That's right, 2 square root of x, and it's actually plus or minus, isn't it?
Oh, yeah.
And so that's something like this. Do you agree?
Yes, I agree.
And it's that y square. It's the square on its side. All right. We're going to take this. This is our piece of real estate, and it's got to go around the x-axis. I like for that to set the language. What kind of language are we in? Dx or dy?
We're going to use dx.
We're going to use dx. All right. We're revolving. What's your favorite Greek letter that you need when you're revolving?
Pi.
Pi. Very good. We're going to integrate from 0 to,
Oh,
oh,
man.
wonder where that point is.
I think you can find if you set it equal.
Tell me what to write.
Okay. Put x equals 4x.
Well, that's setting y equal to y squared, so I don't know. Is that legal?
Nah, that's illegal.
Okay. How about setting x equal to this one?
Yeah, okay. I was just about to say that.
You were going to say that. I knew you were. Well, what does that get us?
Divide by 2.
Divide by 2. I'm moving up here. I ran out of room. Okay.
Let's see. Square both sides now.
Okay. So x squared over 4 minus x equals 0. So x squared minus, multiply through by 4, okay with you?
Yeah, that's fine.
I think it looks like, now tell me if I'm wrong, it looks like 4. What do you think?
Yeah.
Well, let's check it out. Square root of 4 is 2, and 2 times 2 is 4. And what's 4 equals 4? I think we're okay. If I'm wrong, every teacher in town will call and tell me, right?
Yeah.
Yes, they will. All right, let's go 0 to 4. Now we're rotating, we're revolving. Do you have big R, 2 R's? What you got?
We got 2 R's.
You got
big
2 R's. Big R squared minus little r squared, because you're rotating, you're making circles.
Right.
Do you know which one is big R? I'm going to have to rewrite this and make more room.
Big R is going to be 2 root x.
That's right. 2 root x, and what do I need to do to big R? Square it.
Minus
Take away x, and what do I need to do it? Squared and dx. Great job. You did that perfectly well. And then you could go ahead and solve it, either calculator or by hand, couldn't you?
Yeah.
This one actually would solve by hand pretty easily. Now let's be sure we got all the components. We're revolving. We've got 2 radii, 2 pieces. So we've got big R squared minus little r squared. We've got pi because we're revolving. These are circles. And we went 0 to 4. I think all the pieces are there. What worries me is when it's multiple choice, they do things like they'll leave off the square, and if I'm not looking closely, I won't notice. I'll say, oh, there it is. That's the one, and it's not. So read real carefully, okay?
All right.
All right, thank you for calling in. You did a great job on that volume. Y'all have studied volumes.
All right. Thank
Who's our next caller?
Our next caller is Angela from Lincoln.
Hey, Angela. Angela? How are you?
I'm not Angela.
Are you Minerva?
And Minerva.
Are you?
That's okay. We've solved something at the end of the line.
Yeah.
Minerva from Adamson. Excellent, Minerva. We got you. We got you covered now.
Righty then.
All right. Let's see what we got here. I've got a problem for you that's going to require the calculator. Now, you don't mind me using 84, right? Did you say that was okay?
No, that's fine.
Okay, good. F of x is the arctan of x. What does that mean? Well, we'll figure it out. G of x is x squared. Find the area between the curves. So what do I need to type in my calculator?
Those 2 functions.
Those 2 functions, y1 and y2, all right with you?
Yes.
All right, let me get it typed in, and then I'll put it up for us, and we'll look at it together. All right, here we go. Can you see it? Oh, it's at arctan,
Yes.
and I typed 10 to the minus 1. Is that okay?
Yeah.
Same thing,
Very
isn't
same
it? They'll even tell you that on the exam. Same thing. All right, I'm going to check my mode, because when I have trig, I better make sure I'm in what?
Degree.
What?
Oh, radian.
That's right. Radian mode. If you're a physics student, you must be so careful because you do degrees in physics. All right, now, let's go look at our Zoom 7. Sounds good. There's
Yes.
the arctan, and here comes the x squared. Can you see well enough, or do you need me to do something else? What do you think?
Zoom in.
Do you want me to zoom in a little bit?
Yes.
Okay. Let's see how that looks. Oh, I think that looks better. What do you think? Oh, I can see the
Yeah.
region very clearly now. Now, let's set it up first. What do we need to know to set up the area between the curves?
The integral from the top to bottom.
That's right, integral. Okay, so let's do that
Minus
first. This is my arctan, and it's on top, and this is my x squared, okay? So I'm going to go back to the form just for a minute, the page, someday soon. There we go. And I'm going to say integral, and I'm going to leave that blank for a minute. And you said the arctan was on top. Take away the x squared with respect to x. So far, so good. All right, now I'm going to go back to the machine. And we're going to, now what do we need to find?
The intersection.
That's
with
right. So what are they? How do we find those? Second cal, 5. Enter, enter, enter.
Yeah.
And we thought that was 0. I'm going to write it, and in a minute we'll move the paper. And then we got to find the next one, right?
Close to it.
Is it okay just to get close?
Yes.
No.
Oh, well, you have to.
Right. You're meaning go ahead and get close to it. That's
Yeah.
right. Second cal 5. Enter, enter, enter. Is it okay to round?
Not yet.
Not yet. Second, quit and go home. Store it as alpha A or whatever letter you like.
Okay.
Was that the same number?
Yes.
Yes, it is. So I'm going to put on my paper 8336.833, and I'm going to put dots to indicate that I'm going to keep on going with that. All right. Okay, so that's what I've got written on my paper. True?
Yes.
And notice I put the dots so that they'll know that I'm not rounding in the middle of this problem. Okay, now we're going to go back to the calculator. We're going to use the home screen because they've told us that there's a problem with the tolerance on the graph screen. It's better to do these on the home screen. So we're going to do that. Tell me what to punch.
Math 9.
Math 9, so you didn't even have to look. Good. Do you need to see which one's on top? Arctan is on top.
Okay. Bars.
Bars, y bars, function y1. Minus. Bars, y bars, function y2, comma, what do you need to tell it? X is the variable. I don't know why it doesn't know that.
I don't remember. 0?
0, comma, and I called it A. And then you hit enter and you're good to go. Now, how many behind the decimal for your answer?
3.
That's right. And I'm just going to put .122. I put a 3 because when I have to grade papers, I have to know if you've done it right. All right, let's look and see. Here's how you'll get your points. You'll get a point for the integral and a point for the answer. So be sure you set it up. Now, if you had gotten a negative here, what do you think would have been wrong? If you'd gotten a negative by mistake?
Because there's,
You probably would have had these what?
the wrong, like the
Yeah,
top
reverse.
bottom foot.
So you could just go up and change the sign, but be sure you do that because this is a point or two right here.
Oh.
Hey, thank you guys for calling in, okay?
Thank you for.
You guys call back.
Already.
All right, this is our last caller. Who is it?
Jessica from Skyline.
Hey, Jessica.
Hi.
How are you? We have your picture?
Yeah.
Okay, let's see Jessica's picture.
Yeah.
Looks like you're keeping a secret, Jessica.
Yeah.
You're keeping a secret that you are going to make a 5 on the AP Calculus exam.
Wow, you look pretty cool.
Yeah, baby.
All right, let's see what we got because we've got to finish up. So let's see what we can do. It's a pretty short problem. Let's try one of these, okay? I've got a choice for you. You get to choose which one you want.
Okay. Wait.
As soon as I get it where you can see it.
Y'all can hear me okay?
All right.
I can't hear her on the phone.
Can you hear me?
Not on the phone, but I can hear you on the TV.
Okay. All right. Then you can do this problem or you can do this problem. Which one do you like the best?
The first one.
I do too. That would be my choice. Tell me what the first one is all about.
Hold on.
You want to do U substitution?
Wait, hold on. Okay, it's got. Isn't it arc? No, it's not arctan.
This one is.
That one is.
This one's arctan. You want to do it?
Yeah.
Okay. 1 over what?
10.
10. Arctan of
U, which is 9.
You know what? It should have a plus.
Yeah,
That's what messed you
that's
up.
what I was trying to figure
It should
out.
have a plus. That was me making a mistake. Arctan of what, please?
9x.
Not 9x.
I mean 9. I mean 3.
There you go. 3x over
over 10.
Perfect. You did a beautiful job.
Plus
When I fixed it, that was better, wasn't it?
Yeah. Plus
That's
C.
Oh,
and Ms. Harmon,
Yeah.
on that problem, it was supposed to be 16, right?
Well, I thought it was
Number 22.
18. Maybe it was 16.
We worked it the other day and it was 16.
And it was 16.
Yeah.
Thank you so much for telling me about that. That's number 22. Very good. Thank you for getting that information out to us. We appreciate it. All right. Well, guess what? One more show done. We got some more to go. How many callers have we had today?
We've had 16 callers.
All right, let's get the machine ready. I know Ms. Brzezinski likes to see. What happened to Ms. Brzezinski? I think her phone must have gone out of order. All right, 16 callers. And we're going to have how many lucky winners? 1, 2. Would you announce the lucky winners?
The lucky winners are number 11, which is Veronica from Sunset, and number 7, which is Ruth from Adamson.
Thank you for calling in today. I want to thank my student host Alex from Woodrow Wilson. You've done a terrific job. We have 2 gift certificates for our lucky callers. Alex has already told us who they are. I'll be delivering those next week. So we're glad you called in. We hope you'll tune in next week for Calculus Live. Keep studying. Alex and I are wishing you a 5 on the exam on May the 3rd. Work hard so that you can celebrate when those results come in July. Bye-bye.
All right, thanks for tuning in for today's edition of Calculus Live. We enjoyed bringing it to you. And as a quick reminder, don't forget to send in photos of yourself and your class. We love to be able to show your face on television. Either mail it to us through interdepartmental mail at DISD Box 379 or drop us a line at calculuslive@dallasisd.org. For all of us here at Dallas Schools Television, I'm Daryl, and join us next week for Calculus Live, same time, same place. See you then.